In this video, let's review some of the AP questions using substitution. All right, so the first question says, what is the average value? When you see that average value, you know you're going to be multiplying by 1 over b minus a in front of your integral. And of this function, y equals x squared times square root of x cubed plus 1 on the interval 0 to 2. And so I know that I'm going to be multiplying by 1 over 2 minus 0 of the integral from 0 to 2. So this is a pretty complicated function. Let's go ahead and use some substitution. And so we'll pick for our u x cubed plus 1. If we find the derivative of that, that's going to give us 3x squared. Solve for dx, and that gives us 1 over 3x squared du. Now we make some substitutions. So over here, and I have an error right here, I'm going to go ahead and subtract these because those are x boundaries, and now I'm in terms of u. And so when I make my substitution and I go ahead and write, instead of the square root, I'm going to use the 1/2, the rational exponent there. And so I'm going to have 1/2 times u to the 1/2 times that substitution for dx, which is 1 over 3x squared du. My x squareds will cancel, and I can move the 1/3 out front. That 1/3 times 1/2 will give me this 1/6, and you can see I've dropped those boundaries. Now I can find the antiderivative of u to the 1/2, and that's just u to the 3/2 over 3/2. If I go ahead and make the substitution for u, which was which was x cubed plus 1, then I can bring back my x boundaries and evaluate that. And as a reduced fraction, that should give you 26 over 9. Okay, let's take a look at number 2. Again, we have a complicated function here, e to the negative 4x. So let's let our u equal to negative 4x. The derivative of that would be negative 4, and if we solve for dx, that gives me negative 1/4 du. All right, so then I'm going to have, let's see, oh, sorry, I was looking at the wrong thing. If I substitute in for the negative 4x u, and then for the dx, negative 1/4 du, I can bring that negative 1/4 out front, and I have e to the u du. Well, the antiderivative of this is just e to the u, and so then I can make a substitution for the u, which was the negative 4x, and evaluate it at the x boundaries. That's going to give me negative 1/4 e to the negative 4 plus 1/4, because e to the 0 is 1. And if I reverse these two terms, that'll give me this as my answer. Okay, let's take a look at number 7 next. I'm sorry, let's stop at number 4 first. All right, so in number 4 it says, using the substitution, u is equal to 2x plus 1. So they're telling you what your u is. And we have the integral from 0 to 2 of the square root of 2x plus 1 dx. It's equivalent to what? Now what I want you to notice is that each of our answers have u's in them. So that means we must convert our x boundaries to u boundaries. And so if we let our u is equal to 2x plus 1 and sub in the upper and lower limits, now we have our u boundaries. So that'll narrow down our answer choices. It's got to be either C or E with the correct u boundaries. All right, so we are going to have to do a little bit more work. So let's find the derivative of u, which is just 2, and then when we solve for dx, that gives you 1/2 du. Well, this 1/2 is going to come up front, and now we can really find our answer, because that coefficient with the correct boundaries, and so that's C. All right, let's take a look at number 7. Again, we have, we're given what the substitution is going to be, and if we look at all our answers, these are u's, so that means we need to change to u boundaries. And so if I do that first, I can narrow down my answer choices. If I take the upper x boundary and substitute it in, that's going to give me 2, and the lower boundary will give me 1. So now I have, let's see, 2 choices. Let's go ahead and find the derivative of u, which is going to be 1/2 x to the negative 1/2. And if I solve for dx, that's going to give me 2 square root of x du. Now, if I make some substitutions, so in my change my u boundaries, that's going to be e to the u over square root of x times, and then if I make a substitution for dx, which is 2 square root of x du, my square root of x's will cancel. This 2 will come out front as a coefficient, and I know my answer is going to be C. Let's take a look at number 10 next. For time greater than or equal to 0, the height of an object suspended from a spring is given by this function. And it looks pretty complicated. Already I'm thinking, okay, I've got an inside function right here. What is the average height? That means I'm going to be multiplying by 1 over b minus a on my in front of my integral sign from a time of 0 to 2. Okay, so let's go ahead and first what I did here is I set up my integral, and then I went ahead and set it up into two separate integrals. See the plus sign here? That means I can write it as the 1/2 integral from 0 to 2 of 16 dt plus 7. If I bring that 7, that's the coefficient of cosine out front, integral of 0 to 2 of cosine pi t over 4 dt. All right, so now this is where I'm going to make my substitution for my u's. Now there's no substitution in the first integral, so that one's pretty easy, and I can leave those x boundaries alone. But in my second integral, I've got to drop those x boundaries. Let's go ahead and let u equals pi t over 4. That means the derivative is just pi over 4, and dt is 4 over pi du. All right, so here's what I did. I made this cosine u times, and where I had the dt, I went ahead and switched it out with 4 over pi du. 4 over pi will multiply by 7, and that'll give me the 28 over pi, which I have here. Now, as a pretty simple antiderivative to figure out, this is going to give you 16t, and that should be there should be a plus sign right there. Drop the plus sign somehow. Plus 28 over pi sine, and then I went ahead and plugged the u back in, and I'm going to evaluate at those u boundaries. I'm sorry, t boundaries. Plug the t back in. All right, so anyway, it should give you 16 plus 14 over pi as your final answer. And the last one I wanted to just take a look at is number 11. The function f is continuous, and from 0 to 8 of f of u du is 6. What is the value of 1 to 3 of x times f of x squared minus 1 dx? So already I'm thinking, okay, this is going to be my u. Let's go ahead and let u equals x squared minus 1. That means du over dx is 2x, and if I solve for dx, that's 1 over 2x du. Okay, so right here, we're in terms of u. Right here in the second interval, we're in terms of x. So first thing I want to do is go ahead and change my boundaries. And so if I let 3 be my upper boundary, and if I substitute that into the u equation, that's going to give me 8, and the lower equation that'll give me, or the lower boundary will give me 0. So I know I'm on the right track here. Okay, so I've got the integral from 0 to 8 of f of u times x, f of u times x, times where I had that dx, substitute in 1 over 2x du. These x's will cancel, and I've got the 1/2 that I can bring out front. I know that this quantity is equal to 6 because that's given. So 1/2 times 6 is 3, and that's my answer.